All right, y'all, welcome back. Today we are going to talk about topic 1.2, which is transformations. Okay, we are on page 10 of your workbook. If you do not have a workbook yet, then feel free to just copy them down on another piece of paper. You can always come up here and grab a workbook should you need one. Just let me know that you want one. Okay, I also have them on the page so you can print them off if you have access to a printer. All right. So today we're going to talk about transformations, which I know you guys did in geometry. You did reflections, rotations, translations. You probably also did dilations, where you kind of shrink or expand. We're going to do kind of the same idea here, okay? So over here on the left, I've given just a brief little layout. So take a second and just write down what these things represent, okay? So this, we're going to use absolute value as our base graph here. Just so we have something that we can look at. Now, the absolute value doesn't have to be in every problem. That's going to change. But this is kind of what we call the parent function. Okay, so that's like the basic absolute value, and these letters will become numbers and they'll change. And when they become numbers, that's going to change the way the graph looks. Okay, so the first one is A. So if there's a number in front of the absolute value, okay, so if we have a number in front of that absolute value like we have right there, all right, that is going to either shrink or stretch our graph, make it skinny, or it's going to make it fatter. So if A is greater than 1, so basically if we took the graph, if A was bigger than 1, and we stretched it out like it was made of rubber and we stretched it vertically, that would make it skinnier, okay? So stretch vertically is the same thing as skinny, aka skinny, okay? If we were to compress it, if A is less than 1, so let's say we took a graph, right, and I compressed it, I squished it down, okay, then the graph would get fatter. So think about if we took you, right, and we squished you down, you would weigh the exact same, you would now be shorter and you would get wider, right? The same idea here. Okay, so it's kind of like a cartoon. When they squish the character, right, he gets wider. Okay, so if it's greater than 1, it becomes skinnier or stretches vertically. If it's less than 1, it compresses and it becomes fatter or wider. All right. The h that is inside of the absolute value. Okay, so the h that you see that is inside of the absolute value, that is going to move the graph left or right. Okay, so the h always moves the graph left or right. Now, the thing to remember when it's inside the absolute value or inside the parentheses is that you always do the opposite. So if it was a -4, you would actually go right 4. If it was a +3, you would actually move left 3. Okay, so you always go the opposite. And we're going to get a lot of practice with it here in just a minute. And then the C value, the number on the outside, moves the graph up and down. Okay, so inside moves it left or right, outside moves it up or down. So inside left or right, outside up or down. Inside left or right, outside up or down. All right, so you can kind of get that in your head. And we're going to get a ton of practice with it, so you'll know exactly what's going to happen. Okay, so let's look at this first example, example 1. All right, we're going to kind of just do a different sort of problem here. We're not necessarily going to worry about exactly what this says. We're going to change this question around to make a little bit more sense. Let's say that we had a graph that was f of x, which is the same thing as y, equals the absolute value of x, right? That's just the parent function, okay? That's just the base function for absolute value. And this graph would look something like this. Okay, there's our graph, and then this graph would look like this. So it's just a V shape, and it just starts at the origin. Okay, so that would just be the absolute value. That's the most basic absolute value graph that there is. All right, so now let's say that I gave you a new equation, and I said f of x equaled the absolute value of x, let's say +4. Okay, so you can see how similar these are. The only thing that I've added is a +4 on the inside of the absolute value. So basically, I added a +4 where the h is, okay? And whenever you add a number on the inside of the absolute value, okay, or the parentheses, same thing, absolute value in parentheses, same idea. If I add it on the inside, that's h, that means I'm going to go left or right. but we always do the opposite when it's inside. So this positive 4 actually means move the graph left 4 places. And it's going to be the exact same shape, a V shape. It has just been moved over 4 places. So you can see how similar these two things are, right? This one started at the origin because there was no number inside. This one moved left 4 because of that positive 4 right there, okay? Hopefully that makes sense. Hopefully you're not confused. Okay, the next thing we are going to talk about, there's one other kind of transformation. All right, y'all, so the next thing we're going to talk about is when we reflect over the x-axis or the y-axis. So we're going to talk about example 2 right here, okay? So first we're going to talk about when you reflect over the x-axis. So if you want to flip something over the x-axis, so let's say that we had a graph, right? And I drew a graph in here on example 2, right? And we all know that hopefully that's the x-axis, that's the y-axis. So basically I want to take the graph and I want to flip it upside down. Okay? I want to flip it over, right? That's kind of the goal here. I want to flip it upside down. So this original graph right here, x squared minus 2, okay? The square just tells us that it's going to be a parabola shape. So it's going to be like a U shape or an N shape, okay? So if I were to graph this one, this minus 2 is not inside the parentheses, right? So it's outside. It's where the C is. So this minus 2 is going to move the graph down 2 spaces. So this is what the original graph would look like. That equation that they gave us, this is what it would look like. There's that graph. So we're going to call it f of x right there. Okay? Now what I want to do is I want to take this equation and I want to flip it upside down. Okay? In order to flip it upside down, we have to put a negative in front. Okay, we're going to put a negative sign in front of the x. Okay, so we're going to put a negative sign in front of the f of x. So if I were to do that, this would become f of x equals negative, and everything else stayed the same. Negative x squared minus 2. Okay, negative x squared minus 2. And then I would distribute this negative sign, just like I would always do. So negative x squared and a negative, make that a plus 2. So this would be my new equation. And I would probably call it g of x instead of f of x. But there's my new equation. So let's say again I wanted to flip this upside down. All right? So here's where this graph started. All right? And then I want to take this and I want to flip it upside down. So to flip it upside down, I move it 2 places up because of that 2, and the negative makes it flip. So if you see a negative in front of the whole thing, right, that means you're going to flip it upside down. Okay? You're going to flip this graph upside down. So reflect across the x-axis, there's a negative sign in front. If we wanted to go the other way now, right? So let's say that I had the same exact graph, x squared minus 2. So the same exact graph that we started with on the last one. So it looks like this. And now I wanted to flip across the y-axis. So now I wanted to flip it side to side. Okay, to do that, we are going to put the negative sign inside the parentheses or the absolute value. Okay, so if it's outside, if it's in front, it goes over the x-axis. If it's inside, it goes over the y-axis. So if we were to do that on this problem, again, the one that they gave us, x squared minus 2, I would make it g of x, put the negative on the inside of the x. right? So I took this problem right here, and I put a negative sign in front of the x. I didn't change anything else, right? Nothing else changed. I just added a negative just in front of the x. And if we simplify this, a negative squared, a negative times a negative is a positive, and then the minus 2 just stays minus 2. So you should notice something about this. These two, right, see if I can fit it on one screen, these two right here are exactly the same. That one and that one are identical, right? So if I were to flip this graph over the y-axis, if I flipped it from side to side, this graph isn't going to change because this is the y-axis, so flipping it over isn't going to change anything, okay? So it's not going to change anything at all, all right? Okay, so that is example 2. All right, let's look down here at example 3. Understand stretches and compressions. Again, we're going to change these directions around a little bit. I'm just going to give you an idea of what the graphs would look like. So let's say that I gave you a graph f of x that was x squared. So I wanted you to just graph x squared, okay? So x squared starts at the middle, starts at the origin, and then it's just kind of a U shape. Now this isn't going to be perfect, as you can see, because it's just a sketch, okay? Now, what if I stretched it out? So I stretched it up. What if my new equation, I made it 3x squared? Right, so I added the 3 in front. And remember that I added a number in front. So if there's a number in front, it's going to stretch it or make it skinny. So if it was 3x squared, still starts at the same point, it's just going to look a whole lot skinnier. Right, so I basically take the sides of the graph and pull them up towards each other. I stretch them out. Okay, that is if the number is greater than 1. Let's say I did a third one where it was like 1/2 x squared. So now it's less than 1. Okay, that's going to make the graph wider. So I'm going to squish it down, which is going to make it wider. So this graph would look something like this. So there's all the things that could happen when you stretch or shrink, right? The red would be a stretch, the green would be the parent function, and the black would be what I call a shrink. We shrunk it down, we squished it, okay? All right, the very last thing we are going to talk about is on page 11. Okay, we're going to do example number 5. All right, identify transformations from an equation. So basically on this, all I want you to do is tell me, where is the graph going to go? Where does it move to? All right, so I'm going to use some colors here to hopefully help us figure out what they are. So if you notice, there's only a couple things that are different here. I have a 1/2 right here, and I have a +3 on the inside. So the 1/2 is in front, so that's the A value, right? And it's less than 1, so this is going to be a compression by 1/2. Or you could say it is a shrink, okay? Because it's less than 1. This 3, this +3, is on the inside of the graph. And remember, inside means left or right. But since it's on the inside, I have to do the opposite. So +3 actually means go left 3. We always do the opposite when it's on the inside. Okay? So I had a compression by 1/2, and I had a left 3 movement. All right? The second one here, example B, has a negative sign, and it has a +2. Those are the only things that are different, right? The absolute value of x is our base function. So there's a negative in front. There's a negative in front of the whole problem. So that is going to reflect over x-axis because the negative is in front of the whole problem. Okay? Since it's in front, it reflects over x. If that negative would have been inside the absolute value, then it would reflect over y. Okay? The last one is +2. This +2 is not inside, it's outside. So that means it is going to go up 2. Okay? So the first one was compression or shrink by 1/2 in left 3. The second one was reflect over the x in up 2. Okay, so that is our 1.2 notes. All right, so what I need y'all to do now is go do your Math Excel 1.2 on Pearson. Okay, if you have questions, please let me know. I will be happy to help you. All right, guys. Peace.